if you can do two things at once, then feel free to chat as or say it out loud if I ask a question. But we are going to cover in two types of infinity, both of which I'm going to relate back to something that's familiar to you guys. So first, I'm going to call this vertical asymptotes. And we're going to explore what happens when you approach a constant value that leads you to infinity. Okay, and how it's so much nicer with calculus because you don't have to graph and technically do all this algebraic thing, but think of it more conceptually. So we're letting the limit as x approaches c of a function. If you notice that it's approaching that constant value and it's unbounded, the growth is unbounded, the y value goes on to infinity or to negative infinity, we then know there's a vertical asymptote that exists. Okay, so an example graph of that would be on the right-hand side. Go ahead and sketch a vertical asymptote at an arbitrary value of c. And you have a typical rational function that approaches infinity from the right and then negative infinity from the left. And what we would do in let's say example number 1 is, let's say you were asked the limit as x approaches 2, not from the left or right, of 2x plus 5 over x minus 2. And let's think of the analytical ways that you guys have learned so far. Your first attack always is direct substitution. Well, if I plug it in, my problem is that now I have a 0 at the bottom, which is no good, right? We don't want that 0 on the bottom. We look to things like, can I factor? Can I rationalize? It's not a complex fraction. However, when you, actually, here's the first question, if you guys can type in the chat. What happens if you do have a factor that cancels? What occurs graphically when you guys have a factor that cancels? Okay, a hole occurs at that factor. Okay, here we can't factor 2x plus 5, and I hear someone else put removable discontinuity. That is correct as well. But yeah, so you have a hole, you don't have a hole there. So the question is, what happens when graphically at the bottom of at x equals 2, when there is no factor that cancels? What's happening at x equals 2? Any ideas? Factor doesn't cancel. Oh, very good. So you know for sure that a vertical asymptote occurs at x equals 2. And now the question is to you guys, when you think about a vertical asymptote, it's like a wall in your graph. And when you approach that wall, it's either you can't cross that wall, so it's forcing you to go up to infinity or forcing you to go down to negative infinity, one of the other two, one of those two. So for sure, your limit is going to be some type of infinity. And now, so to determine without looking at the graph, whether this is positive infinity or negative infinity, we're going to do something called a Sine analysis. So we have to look at it whenever there's a question that asks you guys not from the left and right, and you have a vertical asymptote, you should still break down the problem. So you're looking at what happens coming from the right and coming from the left. So set up two problems underneath the initial problem, where you have the limit approaching from the left and the limit approaching from the right. And we know our answer, because the bottom is undefined, is going to lead us to infinity as an answer. And now the question is it going to be positive infinity or negative infinity? So when I think of a number line, okay, and 2 is on a number line, directly to the right of it, and when we say limit, we're saying really close to 2. So I go about 1/10 of the way. My test number is going to be 2.1 to the right of 2. To the left of 2, I'm going to pick a number 1/10 away from 2, 1.9. And that's going to be the value that I use to test my sines. So when I plug in, let's say from the right, I plug in 2.1. If you plug 2.1 into the top of your fraction right here, into the top of this fraction, what do you guys get? A positive number or a negative? 2 times 2.1 plus 5. Positive or negative on top? Okay, good. Positive. 2.1 into the bottom, positive or negative? Okay. Wait. 2.1 minus 2, is that positive or is that negative? Yes, 2.1 is 0.1, so it's positive. So now you have a positive divided by a positive, which overall is positive. So then your answer to this is limit as x approaches 2 from the right. We're going to anticipate the graph to go to positive infinity from the right. Okay, and then now from the left. Okay, so from the left, we're going to use 1.9. If I plug 1.9 into here, do you guys get positive or negative into the top? Good. Positive. Positive or negative when you guys do 1.9 minus 2? Okay, so good. So positive over negative. A positive divided by a negative overall is negative. Good. So positive infinity on one end. So it's going to look like that, right? From the left, it's negative infinity. From the right is positive infinity. So together, when I'm asked the initial question for limit as x approaches 2 of 2x plus 5 over x minus 2, I'm going to say this does not exist. Okay, because one is going to positive infinity, the other one's going to negative infinity. If I did my sign analysis from the right and from the left, and I got both of these were positive infinity, I would say that this is positive infinity. Okay, it just qualifies how that limit doesn't exist by saying positive infinity. It's just being more specific. If both of these are negative infinity, a possible answer would be this is negative infinity. Okay, so we're going to do one more example of this, and this time I want you guys to work through this problem with me. Okay, example number 2. Limit as x approaches negative 3 of x squared plus 2x minus 3 all over x squared plus 6x plus 9. So limit as x approaches negative 3 of x squared plus 2x minus 3 over x squared plus 6x plus 9. Here's a moment where I'll say, hey guys, if I'm going too fast in factoring this and you don't remember how to factor a trinomial, don't worry, don't be embarrassed about that. I've had that happen before. Come see me for a tutorial if that's the case. But guess and check wise, you guys can factor this to be, and that should be your first attempt, right? We see a trinomial, we should factor. We should see what happens when we factor. So x plus 3, x minus 1, all over perfect square trinomial, x plus 3, x plus 3. So now you guys notice what happens. Okay, cancel out. What happens at the canceled out factor? Well, for sure we know a whole occurs. Good, at x equals negative 3. And so what we have left on our homework assignments before this, we did direct substitution and it worked out nicely. We got a finite limit, we got a number. However, on this one, when I plug it in, I noticed that, this is undefined. And if that's undefined, then we now know we have a vertical asymptote. Okay, so our answer is going to be some type of infinity. However, I can't just say negative infinity, positive infinity, or does not exist without examining it from the left and from the right. So here's a question, kind of a trick question of sorts. Can you guys tell me a number? Oh, I didn't mean to do. Okay, left. Can you guys tell me a number to the right of negative 3? What's a small number to the right of negative 3? Okay, so I see some of you guys put negative 2.9. Good. Nobody put negative. Nobody put negative 3.1. Okay, so we want to think of negative numbers on a number line, and we have negative 3 to the right of that would be negative 2.9. Don't do numbers that aren't within a fractional amount of negative 3. So like negative 2 is too big, negative 1 is too big. So negative 2.9. Can I have you guys do a sign analysis so we know some sort of infinity is our answer? Now we're trying to figure out if it's positive or negative infinity. So you guys figure that part of it out. I'll give you guys a second. If your name starts with A through M for first names, can you guys do from the right-hand side? If your name starts with N through Z, can you guys do the left-hand side? And then type your answer into the chat for me, whether it's positive or negative. Oh, and can you guys say whether it's right or left that you did? Okay, and then you guys, this is, as you're doing it, very good. Right is negative. Left, I haven't seen anyone doing the left one yet. Very nice, you guys. So left is positive. And then together, when we mesh both of those together, our final conclusion is that the original problem does not exist because we have a negative infinity and we have a positive infinity. Okay, so we're gonna move on now and talk about the other types of asymptote, which I would say, you guys, the majority of your limit type questions is vertical asymptotes. I've seen an occasional horizontal asymptote, but maybe on the like older exams, I haven't really seen it in the new AP exams in recent years. However, it's a good way to tie into the things that you guys have already learned. And once I mentioned this, some people were like, oh, you know, once you started talking about it, it's algebra 2 trig. Okay, so horizontal asymptote are going to be looked at through the lens of limits at infinity. Okay, what do I mean by that? And I saw a couple of people do homework too, which I really meant for you guys to do it after this lesson because it's gonna make it so much easier than what I saw some of you guys do on your homework assignment. So it's limit, we're looking at now instead of, so it's just compare and contrast, you guys. The values that you guys see here are constant values. X is approaching a constant value. Okay, those are your vertical asymptotes. Versus horizontal asymptote, we're looking at what happens when we let X grow really, really big in a positive direction. And what happens when we let X approach negative infinity, get really, really unbounded in a negative direction. And if they tend towards a limit, then we notice that that limit is the horizontal asymptote. So the horizontal asymptote in these two cases are y equals L. So sometimes it's just a limit question. If it's just a limit question, you just provide your constant value. If it's asking for what the horizontal asymptote is, the horizontal asymptote is a horizontal line, so we would say y equals that value. And so just a quick graph of what this means. And so if you guys are looking at a horizontal asymptote and you're letting X go to infinity, and you notice that this branch of your function is headed towards this, this value of L, that is your horizontal asymptote in a positive infinity limit. Okay, versus if you guys were in headed towards negative infinity, what that would look like is same idea, except for you're now letting X grow unbounded in a negative direction. And you notice that your graph is tending towards L in this direction. Okay, and so both of those, we would make the conclusion that y equals L is your horizontal asymptote. So let's go down and summarize this. And you guys will, this will be familiar to you. This will sound like algebra 2 trig in a limits fashion. Okay, so limit as X goes to infinity of a ratio of two functions, f of X over g of X. Most likely they will be polynomials. So you're like looking at f of X and you're looking at g of X, and you notice that the degree of the function on top and bottom, those are the degree, remember, of a polynomial is the highest power. So if the degree of f of X, your top, is bigger than your bottom, so, and we're talking about degree being the highest power, then we call this, you guys will hear me, and even picture it in terms of what a person looks like. This is a top-heavy function that we're looking at when f of X has a higher power than g of X. So if you let X grow unbounded, think of plugging 1,000,000 into the top and the bottom. Okay, if the top is a million and then you're taking that and then you're cubing it, or you're taking it to the 5th power versus on the bottom is only squaring it, then what happens is the top grows bigger than the bottom or faster than the bottom. And so we say it goes to infinity. Well, if it goes to infinity, what that would look like is you have a graph and then you're letting x get really big, but then it's going towards infinity. So there is no horizontal asymptote. There is no there isn't anything that's stopping it from growing as x goes to infinity, as opposed to it's tending towards a value. So these cases, you're seeing like an exponential growth. It's growing bigger and bigger. There is no horizontal asymptote on the top. Okay, so top heavy, it's infinity. So our conclusion is, if the question was asking for what the limit is infinity, but our conclusion is there is no horizontal asymptote. Okay, so then the other case would be, what if you guys are bottom heavy? Okay, so g of x is on the bottom and the degree of it is bigger. We would say we're bottom heavy. And so let me have you guys think of this in the context of a fraction, and I want you guys to type your answer out. Okay, so if you were to plug a million into a fraction and your bottom is just outgrowing your top, you'd get like a fraction like this, 1 over a million. If I plug in a trillion, I'll get 1 over a trillion. What is, as I increase that value, what is that number getting closer and closer to? 1 over a million, or very good. The fraction's getting smaller and smaller until you get to 0. Very good. So 0 is a finite value. So when we get a finite value, we see that it's actually our horizontal asymptote. So y equals 0 is my horizontal asymptote. Okay, so you have 2 cases in which you guys have horizontal asymptotes: when you're bottom heavy, and then when also your degree on top and bottom are equivalent to each other. So they're both kind of like growing at the same rate, so therefore something else happens, right? So the degree on top and bottom, you notice, are equal. And you might remember this from Algebra 2 Trig, Pre-Calc Honors, as a review, is they kind of cancel each other out, and what you get is the ratio of leading coefficients is your answer. So everything else is negligible except for the things that control it out at the front. So I'm going to do a couple of quick examples here. I'm very conscientious of the time. So limit as x goes to infinity of 4x squared plus 50 all over x cubed plus 80x. When we talk about infinity and we talk about letting x get really, really big, what happens is this stuff right here controls everything. Those are the leading terms. Okay, everything else is negligible. Even though you have x's with smaller powers at the tail end of that function, it's not going to matter as you go out to infinity. What controls the growth is the leading terms, or the highest degree on top and bottom. So here you guys have is this top heavy, bottom heavy, or is it equal? Okay, bottom heavy. So when I'm asked for a limit, if this was just my question, the limit is 0. Okay, L equals 0. Okay, if we're asked on top of that, what is the horizontal asymptote? I would say y equals 0 is the horizontal asymptote. Okay, and that's all we would have to do for that problem. Okay, second example, you guys have limit as x approaches infinity of 4x cubed minus 5x squared plus 3x minus 1. The bottom you have negative 7x, negative 25, plus 5x cubed. Okay, top, bottom, or equal? Top heavy, bottom heavy, or equal? Aha, I tricked someone. Okay, look at the chat, you guys. There's a war between top, or equal. So now maybe the people who are answering now are noticing that it actually is equal. And so watch for that on as a trick AP question. Is your top is when we're looking at the degree, we're looking at the highest degree. So really, this stuff right here is negligible when you guys are talking about infinity as a growth. So this stuff is not going to matter. So what happens is what I highlighted is going to control the growth. And so you want to think of, even though it's algebraically illegal, you want to think of it as like, okay, this kind of, if we're talking about growth, this kind of cancels each other out. Okay, so what we're left with is the leading coefficients and the ratios of that. So this limit, when it's equal to each other on top and bottom, is 4/5. If I'm asked for what the horizontal asymptote is, my horizontal asymptote is y equals 4/5. So on tonight's homework, if they don't ask for horizontal asymptote, you don't have to say it. But if they ask for just the limit, all you guys are doing is providing the top part of it. 4/5 is the limit. All right, last example, you guys. So this, I think you guys can spot top heavy. Top heavy is just if the higher power on top is bigger than the bottom. But I know some students get stuck in, and actually the work on this from the one student I checked was a lot more involved than if you just did the analysis this way. So I wanted to make sure you guys saw something like this problem. Okay, so kind of a tricky question. Okay, I know it's algebraically illegal for me to take the square root of -3x and it separate from the square root of x squared. Okay, we were taught that's a big no-no. Okay, but when we're talking about relative rates of growth, or when I say relative rates of growth, the growth when you guys are going out to negative infinity or positive infinity, this stuff is not going to matter, right? That stuff's not going to matter. So really, we're looking at the square root of x squared. And even though that's algebraically illegal, we can think of it as just, well, what happens when you take the square root of x squared? What do you guys have left? If you take the square root of x squared, what do you guys have left? Okay, technically just x, right? So this portion of it is just, that highlighter is way too fat. Okay, so it's equal to just x. Okay, and the coefficient that you guys don't see there is 1. But what's the square root of 1? Okay, just 1. And so if I now look at top and bottom, do I have top heavy, bottom heavy, or equal? Excellent. They're equal because it's x to the first on top and x to the first on top. And so if they're equal, then the limit does exist. We have a ratio of the leading coefficients. We have 1/2, 1 on top, 2 on the bottom. Here's the tricky part with the square roots that I want you guys to be aware of. This was all with the intention of examining it as we go to negative infinity, which is a really large negative number, right? So if what you want to go through and do now is a sign analysis. If I were to plug a negative number in on top, square that number, and then take the square root of it, I would end up with a positive or negative number. I'll say that again. If I plug negative infinity in, square it, and then take the square root, would it be positive or negative? It'd be positive. That's right. If you take a negative number and you plugged it into the denominator, the bottom, would you guys end up with a positive or a negative number? Good. So we have a positive divided by a negative. So overall, that gives me a negative 1/2 as the limit. Okay, so be aware of signs. The same thing when it's top heavy. You guys want to determine, is it going to be, it will be infinity, but will it be positive infinity or negative infinity? So we have negative 1/2 as our answer. And if the question asks for horizontal asymptote, my horizontal asymptote is y equals negative 1/2. Okay, so I am going